Welcome to this short course, which will introduce you to lockout-tagout with an energy isolation procedure at Siemens Gamesa service. By the end of the course you will be able to understand what an EIP is and why they are used in Siemens Gamesa, who is allowed to use an EIP and carry out LOTO, when to use an EIP, how to follow and complete an EIP. All companies have a duty of care to protect their personnel from hazardous energies while working on systems or equipment in the wind turbine generator. The procedures implemented concerning safe work practices when working with hazardous energies are listed below and can be found on Process House BIC. Control of hazardous energy process is designed to prevent injuries and fatalities from hazardous energies via the use of energy isolation procedures. EIPs are step-by-step procedures for identifying, de-energizing, isolating systems containing hazardous energies and verifying zero energy state. Control of hazardous energies, COHE. To protect personnel from hazardous energy while working on systems or equipment. Lockout-tagout or LOTO. LOTO is the process of removing the energy, isolating and securing equipment to attain and maintain zero energy state. LOTO secures equipment from reconnection from system failure or human actions, decreasing the chance of incidents. LOTO improves communication by identifying who is working on what system. Here you can see the general LOTO steps. Click on each bullet to get more information. Disconnect, to ensure the necessary equipment is isolated and any stored energy is dissipated. Zero energy state. Lockout-tagout is applied preventing restart or re-energizing of the equipment. Ensure each person has a personal lockout-tagout device that prevents re-energizing the equipment or system. Check instrument. Make a hot measurement on an instrument testing device or on a known live energy source to check the functionality of the instrument. Prove zero energy state. Identify correct measuring points in EIP and measure to verify zero energy state at work area. Recheck instrument. Make a hot measurement on an instrument testing device or on a known live energy source to check the functionality of the instrument. LOTO skilled person or team lead. The LOTO skilled person or team lead shall always be responsible at work location to ensure a safe work environment including correct energy isolation. If there are multiple LOTO skilled persons in a team, then it must be agreed who will be the LOTO skilled person or team lead responsible for the EIP. Persons operating under LOTO. Operation under LOTO or working in an area where LOTO is being performed. For more details on the roles and responsibilities, see INS 55483. What is an EIP? EIPs are additional safety measures to protect personnel from hazardous energy. If it takes 3 minutes extra, it is worth it to save somebody's life. EIPs are a step-by-step energy isolation procedures for identifying, de-energizing, and isolating systems containing hazardous energies, and verifying zero energy state. For all work on a wind turbine generator where hazardous energy is present, then an EIP should be used. EIPs are used for electrical systems with voltages below 1000 volts alternating current and 1500 volts direct current, as well as for all mechanical and hydraulic systems containing hazardous energies. There may be the requirement for an EIP to support the work on or near the main wind turbine transformer, in which case a boundary of the EIP shall be defined which clearly states the scope of where the EIP ends, and where higher voltage regulations should then be used. EIPs will state if a point of isolation should be locked and tagged or tagged only. All LOTO-skilled persons and team leads responsible for LOTO must have access to EIPs. EIPs can be used on a paper format or electronic version, for example on an iPad or tablet. It is the responsibility of the LOTO-skilled person or team lead to complete the EIP. EIPs should be completed in real time. If there is a conflict of isolations between the work instruction and the EIP, then the EIP will take preference. Each wind farm will have a set of EIPs allocated which will cover day-to-day service and troubleshooting work. If you require an EIP which is not covered by the existing set of EIPs, then please contact the Control of Hazardous Energy team. If you find an error on an EIP, or require an amendment, then please contact the Control of Hazardous Energy team. To use an EIP, you will have the role as a LOTO-skilled person or team lead. As this person, you will have full responsibility of the EIP. To meet the requirements of this role, you will be maintenance or troubleshooting technician as per Wind Technician Competency Framework. Before removal of any LOTO devices, the nominated person or site manager shall click on bullets to obtain more information. Verify the employee is not on premises. Attempt to contact the employee to verify task, equipment. Make all reasonable efforts to contact the employee who applied the device. Follow Lost Key Procedure INS 55483, Appendix 6, for guidance on how manage lost key or absence of employee situation. However, if he or she is unavailable, site management must click on bullets for more information. Verify the equipment or system can be safely energized. Approve any removal of locks and report it to local EHS. Document the removal of LOTO devices under authority of another capable and trained LOTO-skilled person. Record that the employee's lockout device was removed. Inform the employee upon return to site and before he or she resumes work that their lockout device has been removed. It is not allowed to work on energized systems or components where there is a risk of contacting exposed energized parts, except for very restricted circumstances such as performing verification of zero-energy state or voltage testing, current measuring and discharging, error detecting or troubleshooting where reasonable efforts have been made to troubleshoot with zero energy, replacing and handling of UPS batteries, all electrical conductors, circuits, equipment or parts, moving or rotating machinery and pressurized systems, shall be considered energized until isolated, locked out and tagged out and a zero-energy state is verified. As shown on the previous slide, one of the permitted circumstances to working with live systems is when troubleshooting. When troubleshooting, technicians must use the troubleshooting EIP with the following caution. This troubleshooting may involve live work or testing, which must be carried out in accordance with INS 55483. Troubleshooting activities under this EIP shall not involve the removal or disconnection of components from electrical or hydraulic systems. During live work, if a fault has been detected and subsequently needs repairing, then the live work is stopped, and this EIP is closed. The repair work shall be carried out using the relevant EIP for the system or task. When live troubleshooting, technicians must use the troubleshooting EIP. During live work, if a fault has been detected and subsequently needs repairing, then the live work is stopped, and this EIP is closed. The repair work shall be carried out using the relevant EIP for the system or task. See below example flow of troubleshooting with EIP. Live troubleshooting. Troubleshooting EIP permits technician to access wind turbine and perform live troubleshooting. Error detected. Now that fault has been identified, technician must now close troubleshooting EIP. Replace faulty component. Based on troubleshooting, component can be replaced using relevant system EIP. Turbine operational. Work is complete, system EIP can be closed. The EIP header will contain details such as the EIP number, title, location, unique code, revision number and date, as well as the digital signatures of the author and approver. Wind turbine type. Turbine type which this EIP is applicable. Work location. The location in the wind turbine where the work will take place, such as tower, nacelle, hub, blades, etc. Work to be done. This is a short description of the work that is permitted under this EIP. Any limitations to the EIP will also be mentioned here. Associated documents. Details of any associated documents will be listed, such as the relevant risk assessment, method statement, service manual, and electrical diagrams. Each EIP suite will have an associated document matrix which will list all EIPs, review dates, and associated documents including work instructions. LOTO skilled person or team lead. This is the name of the person who is responsible for the EIP and the team when carrying out the work. Persons operating under LOTO. All other team members that are in the work group. Date of work, as expected. Turbine ID. Can be turbine serial number or local turbine number, for example 2,301,234 or T06. The transfer of control section of the EIP is the first section of the EIP, and is used when safely accessing and stopping the wind turbine generator prior to any work. Steps 1.1, 1.2, 1.3 are optional based on regional requirements. Transfer of control for wind turbine. The time in which the technician has had permission to access the wind turbine, for example permit to work. Coordinator name. The name of the person who has granted permission for the turbine to be accessed, normally a coordinator. Permit number. The permit number which may have been given by the coordinator or customer. This number can also be the order, permit number, or left blank as applicable. Establish local control. This step is in reference to switching the wind turbine into local control, and then stopping the wind turbine. Once the wind turbine has been safely stopped and placed into local control, then this step can be completed, which will automatically add in a time and date stamp into the appropriate field. Mandatory workflow. The example workflow shown is a mandatory workflow and therefore must be followed fully for the work or testing described in the EIP. The next slide explains how to identify optional workflows. Optional workflows. Within the EIP, workflows can also be optional. The main purpose of optional workflows is to provide the technician with flexibility, and also where technical variances exist. Optional workflows can be identified by the yes or no radio buttons. These should be completed to indicate whether or not a workflow has been used. The workflow of the EIP often starts with a caution step in which any relevant points of caution are mentioned prior to isolations being made. Examples of this are working near pressurized systems. Blades must be in stop position. Arc flash levels, if higher than PPE level 1. Loss of lighting. Smoke alarms will be disabled. After POI application has been completed, any further points of caution are mentioned prior to zero energy verification or work progressing. Examples of this are waiting time for system to discharge. Description of any live voltages or power that may still be present during the work or testing, such as main incoming supply to turbine. UPS batteries remain live. Point of isolation. Points of isolation are listed in order of application with appropriate instructions to lock and place caution notice. For isolations which cannot be locked, then the statement will read to place caution notice only. Once each point of isolation has been made, the EIP should be completed by ticking the completed box. This will automatically add in a time and date stamp into the appropriate field. There may be an area to add in the number of the LOTO device number for the associated isolation. This will then pre-populate the remainder of the EIP when this isolation is listed. This is not mandatory and may be removed in future revisions. All isolations listed in the point of isolation application step must be completed before work is started. When working with hydraulics, there are additional steps required after point of isolation application to ensure that the system is at zero energy. These steps will be listed in the hydraulic depressurization step and must be followed and marked as completed before work begins. When hydraulic power has been restored for any part of the work or testing, then it is important that the hydraulic depressurization steps are followed again before any further work or testing begins. Once all isolations are completed, the next step is to ensure that the system or work area is at zero energy before any work begins. This step will provide the prompt to verify that the electrical system is at zero energy and will be shown with either points of verification, point of work, or both as shown. When power has been restored for any part of the work or testing, then it is important that the zero energy verification steps are followed again before any further work or testing begins. Please see INS 55483 for further instructions when verifying zero energy. Precautions. This step must be signed by the LOTO skilled person or team lead to verify that all of the steps listed in the EIP have been followed, and that it is now safe to begin work or testing. The steps relevant will be mentioned within precaution statement. Carry out the work. Work or testing can now begin. Restoration of motive power allows the technician to restore power to a system or component in a controlled manner, for an essential reason or key point in the work, such as testing, making adjustments, aligning rotor, etc. The essential reasons will be mentioned on the EIP. At the top right of the restoration of motive power step, there are radio buttons to select whether or not this step is required. Select yes or no to show if the step is to be used or not. The LOTO skilled person or team lead shall always make sure that they have supervision of all team members when systems are being restored, and that the area is clear of all persons, tools, and equipment. Also, all guards and covers should be in place where practicable. Safety from the system should always be maintained, and any relevant instructions will be defined in the EIP. Each isolation which is permitted to be restored will be listed with an associated restoration of motive power box. The restoration of motive power box will contain a number of boxes, which are to be used to log when the isolation is removed and reapplied. When the checkbox is ticked, then the time and date field will automatically be stamped. When an isolation has been removed as part of the restoration of motive power process, then it must always be reapplied. Isolations must not be removed permanently at this stage of the EIP. There can be many essential reasons for a restoration of motive power to be included in an EIP. The essential reason and the permitted isolations will always be listed. Some examples can be seen below. Removal of rotor lock to enable rotation of hub to access another blade. Removal of yaw lock to enable rotation of nacelle for inspection or lubrication of yaw ring. Removal of hydraulic isolations to verify pressures following replacement of components. Removal of electrical isolations for your motors to test motor consumption. Now that the work or testing is complete, the next step is to begin to remove the isolations and bring the wind turbine back to normal conditions. Precaution. Before isolations are removed, it is important to ensure that the working party has been informed that isolations will now be removed. This step must be signed by the team lead to indicate that this has been done. Point of isolation removal. Points of isolation will be listed in order for removal, and once each point of isolation has been removed, the EIP shall be completed by ticking the completed box. This will automatically add in a time and date stamp into the appropriate field. Not all isolations are required to be removed at this stage of the EIP, and may be removed after the clearance and cancellation steps. Clearance, when work or testing has been completed, or when the work or testing is to be cancelled, the LOTO-skilled person/team lead shall complete a clearance signature checkpoint to confirm that all persons working or testing under the EIP have been withdrawn and warned not to continue with work or testing on the system described on the EIP. The work area has been cleared of all tools and equipment. All guarding and access doors have been replaced. The wind turbine is in a safe condition to be returned to service. Should any of the above conditions not be met, then this must be detailed on the EIP and communicated to coordinator, customer, or site management. Cancellation. After the clearance step, the LOTO-skilled person or team lead is now prompted to ensure that all items associated with the EIP are accounted for, and that any remaining points of isolation can be removed, and that the work is now completed. Point of isolation removal. As mentioned in point of isolation removal, some isolations may be removed after the clearance and cancellation steps, such as rotor locks, service valves, and electrical isolations exterior to electrical panels. If all isolations have already been removed, then this step will contain no isolations. The transfer of control section of the EIP is used when safely putting the turbine back into operation. Step 4.2 is based on regional requirements. Transfer of control. Once the turbine has been restarted and placed back into remote control, then this step can be completed, which will automatically add in a time and date stamp into the appropriate field. Surrender record. The purpose of the surrender record is to record the progress of work or testing that is to be continued beyond 1 working day, or the point at which the EIP is to be transferred to a new LOTO-skilled person or team lead. When an EIP is placed into surrender, then Section 1 of the surrender record must be completed. When work or testing is to be resumed by the same LOTO-skilled person or team lead, he shall complete Section 2 before resuming with the work or testing. Where work or testing is to be continued by a different LOTO-skilled person or team lead, then the surrender process or handover should be carried out face-to-face where reasonably practicable. The new recipient of the EIP shall complete Section 2. It is recommended that if a new technician is now responsible for the work, that all safety precautions listed on the EIP are reviewed and confirmed before continuing with the work or testing. You have just completed the EIP course. Before finishing the online course, we will check that you have understood all the concepts. You will take a